Assalamualaikum warahmatullahi wabarakatuh, and a very good morning if you watch this in morning. So today I want to talk about signal analysis of periodic and aperiodic signals. Question 2. My name is Muhammad Jamil Khair bin Abu Bakar with my partner Shahrul Ikmal bin Khairul Anwar. So this is the signal and system subject lectured by Madam Nur Khairiyah binti Ibrahim in Unike LBMI. For task 1A, xt equals to in bracket of -2 for 0 smaller than t smaller than 2 and 0 otherwise, and we got ht equals to -3x in bracket t over 2 plus 1. So we integrate over one period, and then this is the final calculation for the ht. 6 for -2 is smaller than t and smaller than 2, 0 otherwise. So ck equals to 1 over t over 2 for the upper limit, and the lower limit is -t over 2. H in bracket t exponent -j k omega 0 t dt. This is the basic formula for the equation, where t equals to 6 and omega 0 equals to 2 pi over t equals to pi over 3. So we insert all the value in the equation, and then we integrate it to become until we get ck equals to 6 over k pi sine in bracket of 2 k pi over 3. So the next step is to find C0. C0 is k equals to 0, where the equation is like this: C0 equals to 1 over 6 upper limit 2, lower limit -2, 6 dt, and we calculate it, so it becomes 12 over 6, and final answer for C0 is 2. So for the C1, we increase the value of k equals to 1, and then we use the equation that we get earlier, ck, to find the C1, and then we got the 1.653. So it's the same for the C2. It's the same for C2. K equals 2. C2 equals to 6 over 2 pi sine 4 pi over 3 equals to -0.826. C3 we got 0. C4, still using the same formula, equals to 0.413. C5, 6 over 5 pi sine 10 pi over 3 equals to -0.331. And this is the graph that we conclude of the equation above, from the equation above. So the graph will be look like this: the rectangular pulse signal, amplitude on the y-axis, and time in the x-axis. So -2, 2, y-axis amplitude was 6. Then for the magnitude spectrum, ck over k. So this is the graph that using the MATLAB and also this one using the MATLAB. For the task 1b, all the equation we get from task 1a, and the last equation will be ck equals to 2, k equals to 0, where 6 over k pi sine 2k pi over 3, k not equals to 0. So this is the coefficients table. K equals to -5 to 5. So k -5, ck 0.3307, initial ck equals to 0.3307, ck red 3.1416, -4, ck equals to -0.4135, initial ck is 0.4135, ck red equals to 3.1416, k0, ck2, initial ck2, ck red equals to 0, k equals 5, ck equals to -0.3307, initial ck equals to 0.3307 also, ck red equals to 3.1416. So this is the MATLAB code that we generate in the MATLAB software. So this is where we plot the magnitude and phase spectrum in figure 2. For the figure 1, this is the we plot the HT X label, Y label. We can change it to whatever we want. This one. Also for the subplot for the figure 2, this is where we set our k values, angle, the X label labeled by harmonic k, Y label angle ck red. The title for the graph is phase spectrum of CTFS coefficients. And then so this is the graph that we generate from the MATLAB. So you see, start with 0, -2 research to 6, and then it goes until the 2 follow through. So the 2 at the point 2, it will go straight back until 4. So this is the spectrum of CTFS coefficients. As you can see, -10 research up here, and -2 went up to below 1. So at 0, research back to 2, and then it went on. So this is the harmonic graph. So the results, both analytical and MATLAB results match. Magnitude spectrum shows sign-like envelope. 0 coefficients at k equals ±3, ±6 as predicted. For task 2a, given that h in bracket of j omega equals to ht exponent negative j omega t dt. The upper limit is infinity and the lower limit is negative infinity. So ht equals to, we get this back from the task 1 back there, and then we insert the infinity upper limit by 2, and then the lower limit is negative 2. We exchange the ht equals to 6 exponent negative j omega t dt. So we take 6 to the front, and it will be like this: 6 upper limit 2, lower limit negative 2, exponent negative j omega t dt. And then we solve the equation like this. So with 6, and then square bracket exponent negative j omega t over negative j omega, upper limit 2, lower limit negative 2. So we expand the equation like this, and still in the same question, for only in this part that we need to change its form. So from this equation we will get negative 2j sine 2 omega. So we put the new equation into the original one, and then we cut off the j, so we got this one: 6 in bracket of 2 sine 2 omega over omega. So hj omega equals to 12 sine 2 omega over omega. For the next one, the graph it will be like this. So this is what we got from the MATLAB also. Frequency hj omega. This is the magnitude spectrum. Okay, so for the last one, task 2b, this is the MATLAB code that we generate from the MATLAB, and this is where we define all the information from what we know. So we got the graph. So for the graph, this is actually pretty same with the task 1b, only that I put the axis about negative 4 until 4 for the x-axis. So, and then this is the CTFT magnitude spectrum, 0 until 25 for the hj omega, and the frequency read per second is negative 15 to 15. So this is where we can see at point 0 the value was set until around 24. So This is the magnitude spectrum values of initial Hj omega. For the frequency 0, value of Hj omega initial equals to 12, visual guide the highest. For the next one is 0.785, the value of Hj omega is 10.80. This is the second high for the visual guide. And then the third one for the frequency is 1.571. The value is 0, and this is our first 0. So at the frequency 3.142, value is 0 also, and this is our second 0. And for the third one is 4.712. The value of Hj omega equals to 0, and this is our third 0. So in conclusion, the CTFS of a rectangular pulse is a sine function. Number 2 is energy will concentrate at low harmonics. Number 3 will be MATLAB validates our theory. This demonstrates how periodic signals decompose into discrete frequencies. And then it will be all from us. So thank you for your time in viewing this video. Hope you have a good day. Goodbye.